Students, today we are going to study about the hydrological models. What is meant by the model? What are the basic hydrological models? We are going to study about these. So, what is meant by the model? A model is a simplified representation of real world system. How we represent the real world system in simple terms. It is called a model. So the best model is the one which gives results close to the reality. A good model is is in proximity to the real condition with the use of least parameters and model complexity. So a hydrological model means simplified conceptual representation of elements of hydrological cycle. So what are the applications of the hydrological models? How they can be used in the management planning? So the first one is to understand the hydrological processes. The second one is to predict the hydrological events. The third one is regarding forecasting, to forecast the floods, for planning and management of water resources, for climate impact assessment. So we can apply the model to understand the ongoing processes, to predict, to forecast, for climatic impact assessments, for planning management. So we can use the models for diverse type of the agendas in the hydrology. There are basically three types of hydrologic models. They are empirical model, conceptual model, and physically based model. So what is meant by the empirical model? It is also called the metric model. It is based on the highly simplified relationships. It is usually data driven. It includes statistical models. So these models are empirical in nature. That means observation based models. They are developed using observed runoff and catchment characteristics without considering much of the hydrological processes. So it involves mathematical equations which are derived from the concurrent input and output time series and not from the physical processes of the catchment. So these models are valid only within the boundaries. So some examples of empirical or metric models are the linearity assumption based unit hydrograph theory, catchment characteristic based rational formula for peak runoff, strength tables. Second model is conceptual model. So it uses the simplified mathematical conceptualization of a system. It takes help of a number of the interconnected storages used to represent different components of the hydrological processes through recharge and depletion. So these models are usually lumped in nature. That means they use the same value of the parameters for the whole watershed and ignore the spatial variability of watershed characteristics. There may be the spatial variability of the watershed characteristics from one place to another within the watershed, but this model use the same value of the parameters for the whole watershed. For example, this type of models, we can see Sacramento model, Clark model, Nash model, HBV model, HIMOT model, watershed model, tank model, Modi Drolog model, HEC1 model, Jinan Jiang model, Arno model. So the third model is physically based model. Models are based closely on the mathematical representations of the process physics. It considers the process physics as major components. They represent different hydrological processes through mass, momentum, and energy conservation equations. These models may be capable of considering the spatial variability of land use, slope, soil, and climate to deal with the hydrological processes within the watershed. So, um, it is somehow better than the previous because they consider the spatial variability of the uh, different places within the watershed. As physical models are distributed in nature, they require large amount of topographical, soil, land use, and climatic data to provide a framework to explore the changes in the hydrological cycle due to human interference and climate change for water resources management. A large number of the data are required for this model, so time consuming, and it is not budget friendly. Some examples of this model are top model, SHE model, ISBM model, MIK SHE model, SLURP model, SWAT model, DPHM RS model, TopNet model, MISBA model, Hydrogeosphere model, PIHM model, CatFlow model, CREST, Variable Infiltration Capacity VIC model. And these are the most commonly used some physical models. So this figure shows the PRMS, Precipitation Runoff Modeling System, developed by the US Geological Survey in the 1970s and 1980s. Here we can see the input variables: air temperature, precipitation, solar radiation. Then the next process is interception, throughfall, some evaporation, sublimation, snowpack sublimation, then snowmelt. So go back through the evaporation, surface runoff. Some go to the recharge zone, some evaporation, transpiration, soil zone access, groundwater recharge, groundwater reservoir, groundwater sink, subsurface flow. So from the precipitation to the stream flow, evapotranspiration, so the hydrological components are uh, shown systematically. Their interlinkages, precipitation runoff modeling system, precipitation and runoff modeling system. So we need a number of the data for this to operate this model.